You know what's crazy? So many enterprise organizations pour literal millions into multi-region infrastructure, and yet they still get hit with massive, highly publicized outages. You've seen the headlines. So why does this keep happening? Well, it's because simply deploying workloads to multiple regions isn't some magic bullet for resilience. Welcome to this explainer. Today we're unpacking the critical architectural decisions that actually define a solid enterprise cloud resilience strategy. We're going to cut through the noise and figure out exactly how to bulletproof your production systems.
All right, let's just bust this core myth wide open right out of the gate. A lot of organizations think deploying workloads across multiple regions automatically makes them resilient. Spoiler alert, it doesn't. The real question here isn't whether you're using multiple regions, because let's be real, you probably are, but exactly how those regions participate in serving your live user traffic. It's kind of like having a spare tire, right? Just tossing it in the trunk doesn't actually keep your car rolling if you don't know how to swap it out when you blow a tire on the freeway.
So here's our roadmap for today. We're going to cover the multi-region resilience myth, dive into active-passive standby simplicity, look at active-active continuous availability, check out some architecture on Google Cloud, build a business decision framework, and wrap up by designing for inevitable failures. Let's get into it.
Section 1. The Multi-Region Resilience Myth.
Okay, so this evolution from traditional disaster recovery, shipping backup tapes to some offsite bunker, to true cloud-native resilience really boils down to two main models. On one side, we have active-passive. This is where one primary environment handles all the production traffic, while the secondary environment just sits on standby, waiting in the wings to take over if things go south. And on the flip side, we have active-active. This is where multiple environments are live, serving traffic simultaneously. It's the ultimate architectural showdown. Do you keep a backup waiting on the bench, or do you put all your players on the field at the exact same time? But hold on, before we even start debating which architecture is better, you have to nail down two completely non-negotiable business metrics, RTO and RPO, recovery time objective. Basically, how much downtime can your business actually stomach before the financial hit becomes catastrophic? And recovery point objective, how much data loss can you live with? These business metrics have to dictate your technical approach, not the other way around. Think about a massive e-commerce site on Cyber Monday. They need a near-zero RTO because every single second offline is burning thousands of dollars. But an internal HR tool, that could probably survive an RTO of a few hours with no real sweat. Bottom line, if you don't know your RTO and RPO, you're flying blind.
Moving on to Section 2, Active-Passive, Standby Simplicity.
Now, despite what the ultra-bleeding-edge tech blogs might tell you, active-passive remains an incredibly strong, rock-solid choice for a massive chunk of enterprise workloads today. And the reason is simple. It prioritizes controlled recovery. Because only one region handles your traffic under normal conditions, your infrastructure costs stay way down. You're not burning cash to run a fleet of idle web servers on the other side of the country. Plus, operational management, it's just so much simpler. You deploy code to one primary place, your disaster recovery procedures are straightforward. For teams with, say, smaller engineering budgets or fewer resources, that operational simplicity is literally a lifesaver.
But, there's no free lunch in cloud architecture. The big trade-off with active-passive is the failover time. Your recovery relies entirely on your failover mechanisms executing perfectly when disaster strikes. And because that standby environment isn't taking everyday traffic, you run straight into the nightmare that is configuration drift. I'm sure some of you know this pain. The primary environment gets tweaked, the standby gets neglected, and when you finally need it, boom, things break. Also, you have to accept that failover events will introduce brief service interruptions. Your users are definitely going to notice a blip while you actively switch that traffic over.
All right, let's flip the script. Section 3, Active-Active, Continuous Availability.
So if your target is continuous, uninterrupted access above absolutely everything else, you're looking at active-active. Here, live traffic is distributed across two or more environments at the exact same time. If one region totally tanks, traffic just automatically shifts over to the healthy ones without any manual failover. The upsides here are huge. Picture a user in Tokyo and another in New York. They both get ultra-fast responses because they're being routed to the region closest to them. Your compute resources are always earning their keep instead of gathering dust, giving you incredible resilience against regional failures. For the end user, a massive outage in one zone might mean zero noticeable downtime. It's practically magic.
But, and this is a massive but, this approach comes with a hefty price tag, both financially and operationally. Active-active introduces heavy, and I mean heavy, operational overhead. Your engineering team now has to wrangle complex data synchronization and distributed state management. You're suddenly dealing with nasty issues like replication lag and the dreaded split brain scenario, where a network hiccup makes both regions think they're the boss, leading to total data corruption. Plus, your infrastructure costs are going to skyrocket because you're running fully scaled production environments everywhere at once. And don't even get me started on monitoring. You need highly sophisticated observability to untangle issues across a global grid.
Let's make this concrete. Section 4. Architecture on Google Cloud.
Let's look at how a cloud architect actually pieces this together in the real world using managed services. In a typical Google Cloud active-passive setup, you'll establish your primary production region serving all your users. Then, you provision a secondary standby region. It's there, it's ready, but it's not taking production traffic. For your data layer, you can balance resilience and simplicity by using Cloud SQL high availability, with disaster recovery replication continuously streaming over to that secondary site. The absolute most critical step here, though, is making sure your automated failover procedures are tested regularly. You do not want to discover a typo in your failover script during a 3 a.m. outage. Trust me on that.
On the flip side, an active Google Cloud deployment demands some seriously mature engineering practices. Right off the bat, you absolutely need a global external application load balancer. This bad boy actively directs incoming traffic to healthy cloud-run regional backends based on who's available and geographically closest to the user. Now for the data side, traditional relational databases quickly become a major bottleneck. You're looking at complex cross-region DR, or better yet, fully globally distributed databases like Google Cloud Spanner, which is really the gold standard for maintaining massive transactional consistency worldwide. And finally, comprehensive cloud monitoring and logging is totally non-negotiable if you want to track down traffic routing anomalies across the globe.
So how do we make the call? Section 5, the Business Decision Framework.
Because at the end of the day, business comes first, right? Your decision really boils down to weighing the financial impact of downtime against your own team's operational maturity. If your business can tolerate brief, occasional interruptions, and you're looking for lower costs with simpler management, active-passive is right in your sweet spot. But if you have absolutely zero downtime tolerance, if your customers require uninterrupted access no matter what, and you actually have the budget and engineering muscle to handle complex multi-region syncs, then active-active is your path forward. It's all about finding that perfect balance for your specific application.
Now, whichever path you go down, please avoid these common design mistakes. First off, do not assume your system is resilient just because you drew a really fancy multi-region diagram on the whiteboard. Don't overlook your DNS routing, and definitely don't skip your failover testing. Oh, and you can't ignore data replication latency. Last time I checked, physics still applies, and data can only travel across fiber optic cables so fast. A resilient strategy that hasn't been rigorously tested under real-world, stressful conditions isn't really a strategy at all. It's just a wish. Which brings us to our final topic, Section 6, Designing for Inevitable Failures.
There's a famous saying in our industry: great architects don't design for ideal conditions. They design for inevitable ones. Because out in the cloud, hardware failure isn't just a slight possibility, it is a mathematical certainty. True cloud-native resilience is achieved through continuous validation. It's about making absolutely sure that your end users get a seamless, unbroken experience, even when, not if, but when, those inevitable hardware failures, network partitions, or massive regional outages strike. Your architecture needs to be able to just gracefully absorb the blow and keep on ticking.
And that brings us to a final question for you to chew on. Please, don't choose active-active just because it's the fashionable thing to do or because it looks impressive on a resume. Instead, take a hard look at your actual risk management needs. Be honest about your team's operational maturity. Ask yourself, which architecture truly delivers the right balance of resilience, simplicity, cost, and operational excellence for your specific business outcomes? Ultimately, that's the only answer that matters. Thanks so much for joining me for this explainer, and I will catch you in the next one.